Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at Organic Chemistry 2, and our subtopic for today is soaps. So we're going to see how soaps are prepared in the laboratory, and then we're going to see some examples of how we can be able to detect or predict the soap that is formed from reactions. So fats and oils are usually esters from long-chain carboxylic acids and glycerol. I remember we mentioned esters and the formation of esters through esterification in properties of carboxylic acids. So you can go back and see how those esters are formed, but fats are usually esters. So when you look at the difference now between fats and oils, oils are usually naturally occurring in plants and animals. For example, we have whale oil, coconut oil, corn oil, castor oil. They're usually liquids at room temperature. And then fats are usually occurs naturally only in animals. Examples is butter, tallow, lard from pigs, and they're usually solid at room temperature. So fats and oils are usually important in the manufacture of soap, which is what we are focusing on today. So let's see how these fats and oils are used in the preparation of soap. So soaps are a variety of compounds produced when oils and fats react to sodium hydroxide. So you notice this topic is going to divide the soaps into two. So there's the soaps and then there's the soapless detergent. So the soaps are produced by reacting the oil or fats with sodium hydroxide. They are similar in that they contain long hydrocarbon chain ending with a carboxylic anion to which is attached to a sodium cation or potassium cation. So this is how it looks. So all these can be represented with R. So we have an R, then COO, and then sodium. You will see it being shown in different ways. We are going to see those ways later on, especially when we get to the cleaning action of soap. So this is an example of a sodium stearate. You can see the R part is large. So you see the zigzag when they're representing, and then they show an head. This head represents these parts of the structure, but later on we'll focus on that. So soaps are prepared in the lab by reacting oil with concentrated sodium hydroxide, and then the solution is heated. As you can see, it's being heated on over a water bath. And then after that, during heating, sodium chloride is added in the mixture, and then it is stirred and allowed to cool. And then the mixture is washed and separated or filtered. And then to test the product that has been formed, the small amount of the solid is added to warm water and shaken so that you can see if it's going to lather or not. So on boiling alkali or with fat or oil and hydrolysis reaction occurs. The hydrolysis reaction in the presence of alkali is known as saponification. So we're introducing a term saponification. So in the fast hydrolysis, the sodium hydroxide is used to neutralize the acid. Remember, we said that the fats and oils are just carboxylic acids from esters to form a sodium salt of the acid, removing it from the aqueous mixture. The alkali is always excess so that all the fat is utilized. We replace potassium hydroxide with sodium hydroxide, especially if we want to make softer soaps. Potassium hydroxide is used instead of sodium hydroxide. And then there is a sodium chloride that is added in the process. This helps in separating the solid from the glycerol. And this process of separating is known as the salting out. So it reduces the solubility of the soap in the aqueous layer. So the lower layer consists of glycerol, salts, and unused alkali. That's why it is filtered off to remove those impurities so that it doesn't interfere when you're testing. So this is an example of a reaction. It is important, you see, remember we said it's a neutralization reaction. And when you look at this fat or oil, you can see how it looks like. It's a ester. You can see an alkyl attached to the acid, which reacts with sodium hydroxide. So you notice there is a dissociation or displacement that happens. So the sodium ions displaces um, the alkyl part of the fat, and it's replaced directly with sodium, and then we are left with an alcohol. This is a very common question that is tested in the exam. So let's try to derive the product from different samples and see if we can be able to get the product. So we have this oil or fat. In this case, it has a general formula where R1, R2, R3 can be any number of molecules, and you can see how it is attached to the alkyl part. So when we react it with sodium, the sodium displaces the alkyl part and it attaches itself on the sodium. So this is what detaches itself, and this is where sodium attaches itself. So you're going to see something like this. The sodium comes, attaches itself. So we write R, and then we are going to put it in bracket because this is repeated for the three parts. So sodium is replaced here, here, and here, just like you saw in the previous example. And then the final product, you take our CH2. Remember, this is where the breaking happened. So this is where the OH is attached to form OH, and then CHOH, and then CH2H. Let's look at more examples. So we have this reaction. So the sodium hydroxide, the sodium is going to detach from here. It's going to cause a detachment, and sodium is going to be added from this corner, and the rest is going to react with the OH. So we end up having, so we have sodium. So we have something like that. There are three of them. Then plus the final product, which is CH2 with OH, CH with OH, and CH2 with OH. This is a triol or glycerol. So this is what you get as a product. Sometimes you're given it as an unknown like that, and you're required to write the product yourself. Finally, we have this last one. So the sodium is going to displace from this part, and this part. So we will have sodium. So we're just going to repeat this. Then there are three, and then plus the rest reacts with OH to form the alcohol. And this is our product. So if we look at the overview of preparation of the soap, so we said that the fat, the oil or oil, which is an ester, undergoes saponification, where it reacts with either sodium hydroxide or potassium hydroxide, and it is boiled, and then after that sodium chloride is added to salt out the soap. It helps to crystallize the soap. That's why it's able to be filtered off as a solid. And then the rest of the impurities are removed as filtrate. And then we get our ordinary soap. So that is the basic way of producing soaps in the laboratory. So that brings us to the end in the preparation of soap. In the next lesson, we are going to see how the soap is used for cleaning. So you're going to look at the mode of cleaning of soaps. So see you in the next lesson.